Hello students, welcome to the next lecture on the sequence and series. Today we will discuss about Cauchy root test for the infinite series. Myself, Dr. Garg. You can simply follow my YouTube channel Dr. Harish Garg for finding the various videos on the topic real analysis. So let's start with this video. We will see in our last lecture we have discussed about these 5 tests which are available in the previous link. Now in this lecture we will discuss about the root test. It is also called as the Cauchy root test. We will explain this with the help of 10 to 12 examples so that you can learn very simple method. What is the Cauchy test is? This is a Cauchy root test is if you have a positive infinite series. What is the meaning of the positive is? That is whenever an is greater than 0 for all n, then it is a positive infinite series such that the nth root of this an is L. Then the series is convergent when L is less than 1, and if it is greater than 1 it's a divergent. Make sure that whenever L is equal to 1 then this test will fail, and then we will look about some another test called as the ratio test, integral test, and many more are there. The proof is very simple. We will discuss about the two proof. One is when L is less than 1 and when L is greater than 1. What will happen when L is less than 1? So L is, what is the meaning of the L is? That is a limit here. So we can choose any of the real number R such that this property hold. Now it is given to us limit AL is L, but L is less than of R is here. What is the meaning of that? That means limit is my finite number. So limit is finite, it means there exists some positive natural number m such that this is less than of R for all n. Now our target is to identify the nature of the an. So can you find the value of the an from here? This is nothing but R raised to power n, and you can take the summation on the both sides, you will get here. What is that? This is the series. What is the nature of this series? This is a geometric series, and what is the common ratio is? That is a R which is less than of the 1. So therefore by the comparison test and the geometric series test, the series this is convergent. On the other hand, what is the meaning of L is greater than 1? When L is greater than 1, it means that this limit is greater than 1. What is the meaning of that? It means an raised to power is for infinitely many n. Can you find the value of the an from here? Take nth power, so you can take the nth up there, which is again greater than of the 1 for all n. What is the meaning of that? When an is greater than 1, then the limit is a non-zero. What is the meaning of the non-zero? That means the limit, that is the series, is non-convergent. So once it's a non-convergent, then it means either it's a divergent or it's an oscillating series. But it is given that it's a positive series. So once it's a positive series, so it can't never be a oscillate series. So therefore this series is a divergent when L is greater than 1. Now we will see there are the various examples are there. This Cauchy root test is also called as Cauchy radical test are there. Why it's called as the Cauchy radical test? Because of this 1 by n is called as the radical test. We will discuss about the 10 to 12 examples. So we will see in here. How do you remember that in your examination you can apply this root test? So whenever your an is in the form of power of n, whenever, look at that, this is a power of the n, these are the power of the 2, 3 and so on. So you always apply this root test. Now first question is, you have to discuss the convergence of the series. When n is odd and even, it gives to be here. So you can see when n is 1, it's odd, it's here. You can see when n is odd, I can written as 2n minus 1. So it can be written like here, it odd are here. We can compute the limit. We can see if you compute the limit of this, because if it is a 2n minus 1, it's a 1 upon 2n minus 1. It is a less than 1. So it means it is a convergent. Similarly for here, if it is a 2n, you have to take 2n again. Both in both the cases, both are less than 1. So by the Cauchy root test, the series is convergent. Look about this one. Now in this case, how you can find the nth term of this? So look at that. This is 1 by 2 raised to power 1, 1 by 2 raised to power 2, and it is 1 by 2 raised to power n. Now how you can write this? So it's a fraction. I can write as a 2 over 1, 3 over 2. So the first term is 2 over 1, then 3 over 2 raised to power 2, then 4 over 3 raised to power 3. So I can write this as a 1. So it means it is a n. Now it's a 2 over 1, 3 over 2. So it means it's a n plus 1 over n is my nth term of this series. Now here it's a power of the n, so we can apply the root test r here. We can compute the limit. You can see limits are here. What is the answer of this? It is nothing but my half, which is less than of the 1, so the series is convergent. Look about this one. Again, you can see this says, can you find the nth term of this? So you can see it's a 2 and 1, it's a 3 and 2. So firstly look about the first term. What is the nth term of this? So n plus 1. So if it is 2, then it's 3, it means n plus 1 divided by, it's a n raised to power n plus 1 minus, what is that? This is n plus 1 over n. What is the whole power is minus 1, minus 2, minus 3, and it is minus n is there. So you can write like here. Now once is nth term, so its a power is n, we can apply the root test for here. So we can take the limit. How you can solve this? I can expand them in this part. I can write as n and here. What is the limit n approaches infinity? This is 1. What is that? This is nothing but e. This is 1. What is that? This is 0. So it's a e minus 1 raised to power minus 1. So we all know e is nothing but 2.178. So clearly say that this is less than of the 1. So my root test series is convergent. In this case, it is already given to you an. This is n minus log n over 3n. Now again you can see the power is n, so we can apply the root test for here. How you can find the limit? You can take it separate here. So this is 1 by 3. Again it's a infinity by infinity, so we apply the L'Hopital rule are there. So it is a 1 by 3n of 3 and divided by 3. So it's a 3 will be cancelled out. 1 by n divided by 3. So it goes to the 0 as n approaches infinity. So that you can see it's a less than 1, so the series is convergent. Check the convergence of this. So here you can see x is greater than 0. So x greater than 0 means x can be 10 raised to power 7, x can be 10, x can be 9.3 and so on, but there is no value of the x provided. Again it's a power of the n, so we can apply the root test here. So we can find this root. So what is the limit as n approaches infinity, n raised to power 1 by n? It is always 1. Remember that. So this value is 1. 1 cube is 1, so the limit is my x over 2. So when this will be convergent, so by using the Cauchy root test, this series is convergent when this is less than 1 and also x is greater than 0, so it will be greater than 0, and divergent when x is greater than 1. Or you can say the series is convergent when x lies between 0 and 2 and divergent here. But what will happen when this value is my 1, that is x is 2, then the root test will fail. So once the root test will fail, we will apply the another test like of the p-test, geometric series, we can apply the ratio test or a limit comparison test, we will see. So what will happen at x is equal to 2? If we substitute x is equal to 2 here, this will be 1. So here, can you see which one is that? So this is a convergent series by using the p-test, because what is the p-test is n raised to power p. When p is greater than 1, it's a convergent. Otherwise, whenever less than equal to 1, it's a divergent. So you can see x is equal to 2 is a convergent, so we can substitute here. It will be my convergent R. Look at it here. Again you can see this is a power series. Again there is no nature of the x, so we can apply, this is the nth power, so we can apply the root test. So what is that? When n approaches infinity, this goes to the 0, e raised to power 0 is 1 is here. Again depending upon the nature of the x, if lies between 0 1, then it's a convergent, otherwise divergent. But what will happen at x is 1? The test fail. So what is the value of the at x is equal to 1? We can substitute here. This will be 1. We can write here. Now clearly say that we can't apply the, can you apply the p-test? No. Can you apply the nth term test? No, because when you take the nth term test, what will happen? Limit n approaches of this, it goes to the 0, so we can't apply the nth term test. Is it solved with the help of the geometric series? No, because this is not the geometric series. Can you compare with the limit comparison test? No. So it means none of the tests which are discussed so far is applicable to here. So we will apply this to the ratio test that we will cover in our next lecture. So whatever we will get, we will see, we will write the equality here or here depending upon the ratio test. Again, we will see this example. Again, the nth power are given here. We will find this. So what is the limit of this? So I can write this number as of this firstly. So what is the limit as n approaches infinity? So this part is 0. Again, it will be x. So when this is less than 1, by the root test, it will be convergent and otherwise divergent. Why it's a greater than 0? Because if x is less than 0, it means x is my negative. So once x is negative, so this number will be my here minus of n something minus of, so this number is less than 0. It means the series is not positive. So once it's not positive, then the root test is not applicable. So in order to apply the root test, it means x must be greater than of the 0. What will happen at x equal to 1? If you substitute here, the test will fail. If you substitute this one, now we can apply firstly the nth term test. We will check what is the limit n approaches infinity of this. It is e, which is non-zero. So what will happen if it is non-zero? So it means by the nth term test, the series is divergent at x is 1. So therefore, by using this, we can say equality appears at the divergent. Look at the another example. Discuss the convergence of this series. So again, this nth power are there. You can also apply this here as a ratio test, which will be discussed after this lecture. Otherwise, you can solve this with the help of root test as well. Now, how you can solve this part? I can write this as a of 2, a of minus 2 by n divided by n raised to power n. I can write this number as of this also. Now, as n approaches infinity, this part will goes to the 0. So the numerator part will be 2 of 1 minus 0. What is the limit of this? It goes to the 1. It goes to the 1. So it means it is 1 of 1. That is a square is the answer. Now when it is a less than 1, it will be convergent, otherwise divergent. Again, why it's a greater than 0? Because a square is always the positive value. So that's it, sir. Here. What will happen when a square is 1? That means when you substitute a square is 1 here, I can write this number as of this form. So once a square is 1, it could substitute, it will be here. So can you say which test will be applicable? I can write this number as of n3 by 2. So clearly says that this test is convergent by using the p test of there. So which is convergent because of this. So therefore, when a square is 1, so it will be convergent. We can apply the equality at here. So last two questions are there. Again, the nth power are there. We can apply the limit root test are there. We can find this. What will happen? This is n plus 1, n plus 3 of n, because n square 1 n will be cancelled out. Now what is the limit of this? If you take up the numerator, it is e raised to power 1. It is e raised to power 3. Remember, what is the formula? If you forget about that, 1 plus a upon n of this is nothing but e raised to power a. So here a is my 1 and here a is my 3. So it will be my 1 by e square. What is the e? E is 2.178. It is always be less than of the 1. Therefore, this series is my convergent by the root test. Look about this one. So if you apply the a of n, what will happen? This is 1 by log of log n. Now you can take the limit. N approaches infinity. What is the n approaches infinity? So that will goes to the 0. So 0 is less than 1. Therefore, it is a convergent series by the root test. Few questions are exercise for you. These are the 5 questions. You can try it yourself. These are the answers provided to you. You can find some more 5 questions are there. These are the answers. You can try to solve it and let me know whether these answers, you can get these answers or not. I hope you can simply learn this test. We will see the next lecture on the Cauchy root test for the infinite series. Till then, you can simply like, share and comment my these videos. Best of luck students. Happy learning.